Hello. Hello. So we'll start in 1 or 2 minutes, okay? Anyway, good afternoon, everyone. So my screen is visible, right? Yes. Okay, so once again, good afternoon to all of you. Start today's tutorial of week 2, engineering mathematics, the second part. So this is Rahuldev Ghorai from Tiruvananthapuram, and this the course instructor is Professor Jitendra Kumar from and the course code is this NOC 25 MA19. Okay, so the first we'll, like as usual we do, we'll go through some mainly 1 or 2 slides will be there just to recall what are the theorems we need for this tutorial. Okay, this week 2 tutorial. Okay, so first one is the Green's theorem, which relates a line integral around a simple closed curve to a double integral over the region R, which reads like this. I mean, if you look at it, so this is like this integration, it says that it is, I mean, it is over a simple closed curve C. It's not over some region or something, it's a curve over a curve. If you want to find the integral, if you want to find the integral, line integral of this function, then you need to find mainly this type of. So this you have to remember. Okay, can derive. You have seen also. You can be one can derive this, but yeah, you have to remember this. And then there are two important result. I mean, two important rule you have to remember, formula you have to remember. That is, area of the surface f of x y is equal to c over a closed and bounded plane region R. Okay, so over a the area of the surface f of x y z equal to c over the surface plane region, over the plane region. This is the over the plane region. This is not surface area. This I mean yeah, I mean you can the area of the yeah, it is the surface area. Sorry, it's a surface area, but over the plane region, over the plane region. But this is the another formula is another important. This is one of the important formula. One of the important formula is this, and then another it comes the area of the surface f of x y is equal to c. If R is the shadow region of the surface S is defined by the equation and G is the continuous, yeah, the integral area of the integration of G, the G function over the surface S, where surface S is the f of x y is equal to c. This is more general one, right? If g of x y is equal to 1 mainly, that will give you the area of the surface area of the f of x y is equal to c. I mean, this is more general version. Okay. Yeah, those and the thing is, gradient f dot p has to be not equal to 0. Then only this formula is valid. You will see in your course, this will be mostly, it will be like it is not equal to 0, where p is the unit normal to the sun, to r, to the plane r. Okay, so here also the integration, it is not the type, this type of the integration will be over r, and you want to find the surface area of g of xyz. I mean, I am writing again this one. Okay, so g of xyz over the surface gradient f, over the surface f, where I mean where r is the, if you have a surface like this, let's say you have a surface like hemisphere type of circle. Okay, sorry, hemisphere type of surface, not circle. So like this, then your maybe projection will be like this on xy plane. Okay, whatever you like, you have to mainly project it in a plane, because you know over a plane what is the surface area. Then I mean, that's why you always project it on a plane and then you do the integration. So here r is the projected plane of this. This is the f function, and g is somewhere else. G is something else, some other function. You want to define, you want to find the integration of g over the surface f. Then you take this. You take the shadow region. I mean, you take the projection on the plane, and then you find out the integration. We will see how these are. We will be calculating how we can calculate those. Okay. So then it comes to Stokes' theorem, which is the circulations and the curve, which establish the connection between circulation of a vector field along the closed curve C and the flux, and like this. So this you know also. So it's okay. And the divergence theorem is that the f dot ds. I mean, here f dot ds means f dot in times ds. N is the outer normal. Okay. So this also, you know, one can find out you can find like bridge between two double integral and triple integral, volume integral and surface integral, right? Okay, so I am done with my I mean, I'm done with recalling the theorems which I need for today's tutorial. So if you have any doubt, please ask. I'll just wait for 1 minute. Okay, so if not, we'll start with the first question. So please read the first question. So this, yeah, I mean, reading the question is much more important in these cases because you need to understand over which you want to find integration and all these things. I mean, I want to find the area of the surface over whether over is over a plane, over a different surface, whether you can that if the question is asking, you have to find the surface integration over a domain which can be just a union of some plane, then you don't need to go to that. I mean, that will be just plane by plane you can do. I mean, what I am telling is, let's say I'm not talking about this question. Okay, let's say you have to find out integration. I mean, integration over a plane like this. I mean, this, if you can understand, this is x y z. First is xz. Okay, the xz like this, and then xy in the xy plane in this one, and then like this. This is zy plane, and then you also have this whole plane. I mean, the xyz plane also. So then what you can do, you can easily find out the surface integral by doing first this part. I mean, let me maybe draw it in, so you will understand here maybe better. So if I draw it here like x plus y plus z equal to 1, and this one I just remove it. How does this plane look like? X plus y plus z equal to, right? So this is, suppose this is the plane, and then also you have a plane like I mean y plus z, that equal to 1. See, you got two plane. Now one more plane, let's say some, yeah, x equal to -1, right? That's all. Yes. So now if you see these are the three planes, right? You have the, it's hanging. Yeah, no. So you have this three plane, but if you see it by zooming, so it will be, this will give you the intersection of these three. The intersection of these three will give you another coordinate, another surface, which is the union of, sorry, one minute. I mean, you have to draw in such a way that this will give you intersection will give you one plane. And you will see in the examples where whether like how it is they are using. And here in this iPad you don't see it nicely. So what what I want, this region, this region is the intersection of this region. Then you can do it over this plane, over this other plane, and over through this plane also, right? So once you, yeah, exactly, yeah, this is the thing. So if you want, if you are given to find the integration over the intersection of these three, and the x plus y equal plus z equal to 1, and the area bounded by this y plus z equal to 1 and x equal to minus 1 and x plus y equal to z equal to 1, then you can do it over these three planes separately, and that will be the that's how you can do, right? But if it's a different surface, then you have to use some, let's say it is a surface like x, x to the power 2 plus y to the power 2 equal to z, right? So if you have this type of surface, so this is not the function of which you have to find the integral. This is a domain where you have to find the integral. Then you cannot use that plane formula. And whatever now I told, that's for these two. So you have to, these two, you have to understand that one is over the plane, another is over the surface, but that surface integration also you are transforming to the plane integration. Always you have to transform to the plane. The how you will do that? So here you have this, but the projection of this will be, so projection of this x square plus y square equal to z, and if it is up to z equal to 2 or something, some such thing, then you can put x to the power 2. The projection on z equal to 0 plane will be equal to, if it is up to 2, sorry, up to 2, then this is yeah, this is your projection. So on the if it is up to 2, the projection of this plane on x y axis, this is a z axis, you can see, right? The z axis and x axis, so it will be the, on the projection you can find out by doing the projection. So this, the red line was the r plane, okay? So you need to remember that, because you need here that thing. That's why I'm just explaining. Okay, so you do it for this one. You first read it. We'll do it together. Okay. So the question is, integrate g of x y z equal to y plus z over the surface of the waves in the first octant bounded by the coordinate planes, and the planes x equal to 2 and y plus z equal to 1, right? So there are, the surface is bounded by three planes. One is the first one is the coordinate planes. Coordinate planes mean, you know, right? This is the, if x y z, this plane will be this plane. This is the perpendicular of, like this is x. This will be the x y z plane, right? This, if this is y, this is z. I mean, let's say like this. You have, I mean, this is the yz plane, right? If it is y, if it is z, and this is x, yz plane. And again, this one will be zx plane, and this is will be xy plane. And there will be another plane which will, let's say, maybe it is going like, sorry, it is going like this here. So the bounded by these three region will be one like pyramid type of, right? I mean, this and this, right? So mainly here is that one, and the other side you have like this, and that's the type of plane. So three planes will be there. So how to integrate this function or this surface over this bounded region. You know the formula already, right? So, but what you need to find, you have to find the integration, you have to evaluate the integration, but what you can do, the integration over whole ways, I mean what you need to find this integration over the WEDZE, right? Ways of the first octant. So I'm writing the over which you have to find out, that is this is the required integration integral, right? This is the required integral, right? So what you need to find, G of XYZ this is the one you need to find out. And where if is given, like first of all, it is the union of x y y z z x and x equal to 2 y plus z equal to 1 plane. So this formulation you have to mainly find out, right? So d sigma also I will give. What is d sigma? I mean, d sigma is mostly it will be d sigma will be gradient of f over gradient f dot p times dA, the surface infinitesimal surface. Did you understand this one? I mean, see what is here. I mean the area of the surface over a closed and bounded plane region R is given by this, right? So in this case, you cannot use this one. You have to use this one because you have this. Your surface integration is not over now plane. It is over another surface, which is union of planes. So what you need to do is you have to use this formula. So that is what I have written. G times small it was small g, here is capital G, nothing else. Otherwise the formula is this. Now we will see how does this look like, this ways. So what you can write, this integration, you can write it over first over xy plane. The integration will be over xy plane because depending on the plane, this p and all these things will vary, right? So this will be over xy plane plus over yz plane plus over xyz plane and plus over the plane which is x equal to 2 y plus z. Right. So you have to find out the integration, surface integration over this bounded region, and I now get it up to, like, I can now divide it by the plane. I mean the xy plane, yz plane, zx plane, like this, because it will be easier, right? Now on xy plane, we know z equal to 0, right? So mainly on xy plane, z equal to 0. So the surface here, it will be fxyz. You see, we said f is union of xy, yz, zx and this plane. F is not only this plane, right? So f of xyz is equal to z equal to 0, right? That's a f. So what will be gradient of f? That will be only k cap, right? So gradient of f will be 1, because it is equal to 0 square plus 0 square plus 1 square is equal to 1. And what about p? P is the unit normal, unit outward normal to the plane. So it will be, if it is xy plane, the unit normal will be k cap, right? It has to be k cap because ij plane is varying, so k cap will be the normal. So gradient of f dot p, that modulus will be also 1. Thus what we get over xy plane, this g times d sigma will be, so over xy plane, so g, what is g? What is g? G, you have y plus z, right? Y plus z. But on xy plane, z is 0. So you have this, the over xy plane, y plus 0, d sigma. Now d sigma comes gradient f, which is 1 modulus of gradient of f over f, 1 times dA. dA will be dx and dy, that you know, right? So it will be y times dx dy. But what about this integration? It is, although it is in the xy whole plane, although it is, I am writing xy plane, it will be up to some number because it's a bounded region by this x equal to 2, y plus z equal to 1. So it can maximum go up to x equal to 2. And x, you have seen x can be 0 also, right? So x equal to 0 to 2, and y can maximum be 1, so y equal to 0 to 1. So 0 to 2, y square by 2, that 0 to 1 times dx, so it will be 1, right? So this is on xy plane. So similarly, what you can do for the other one, you can do it for yz plane and zx plane. So what you will see, if you do over yz plane, this g times d sigma will be on the yz plane, right? So this will be I cap j cap, yeah, p will be I cap. So and gradient f will be also I cap. So like that, you will see it will be on yz plane, it will be 1 over 3. Okay. So and over zx again, xz plane, it will be also again 1. Okay. And the last one you need to find out on this plane, on x equal to 2, y plus z equal to 1 plane. So I have anyway done that calculation here. I have given the solution here. See, this is finally, so first one we have seen this, it is on over xz plane, that is equal to 1. and over xy plane this will be 1, but on the on yz plane it will be 1 over 3. Yes, and on the triangular face in the plane x equal to, on the triangular face in the plane x equal to 2, we have x equal to, there also you have 1 over 3, and then you have the slope face y plus z equal to 1, x can be anything. So there are mainly 4 plane if you see it. So that 4 plane will be x equal to 2, y equal to x equal to 2, x equal to 0, y equal to 0, z equal to 0, and then x plus y plus z equal to 1. Okay, so that will be this, because y plus z equal to 1 means this f of x y z, that will be y plus z equal to c, that c is 1 here, and g x y z equal to y plus z equal to, that is also, see these two are same actually given, but it's not always. So y plus z equal to 1, this is y plus z, so that won't be always equal. So y plus z, g as x equal to 2, you can just put x equal to 2, but it does not matter. Y plus z means that p will be I, and gradient f is equal to I cap, gradient f equal to 1. So gradient modulus of gradient f is equal to 1, and gradient f dot p is equal to 1. That implies g d sigma is equal to y plus z you have always. So d sigma will be this gradient of a means 1 over 1 is dz dy, then you just do integration. So at the end you on the ways you just add all those on xy plane, on yz plane, on zx plane, and on the plane like this, means x equal to 2 and y plus z like this. Okay, so that all will give you 8 over 3 plus 2 square root 2. Is it okay?
Yes, sir.
Yes, tell. Hello. Is it okay? So it will be solution for question 0 anyway. Any doubt here? Please. Okay, this is the solution to question, the first 0th question. Okay. So now it's much easier. I think this is just you have to evaluate using Green's theorem, right? So this one you need to find out using the Green's theorem, which is given here. It is given f1 dx, f2 dy, then f2 del x minus del f1 del y. So f goes. Yeah, you do it. I will write the formula, but you try to do it by yourself. And let me know what is the solution you are getting. Okay, so if not, then we'll do this one. So what is the how to do this? First, I'll write what is the formula. Some issue with the Apple Pencil. Just let's see. Yeah. So what is the formula?
So double integral both sides.
Double integral both side. What is double integral both side?
Double integral of f1 and plus double integral of f2.
Why?
Theorem.
No, no, no. Del f2 del x minus del f1 del y dx dy of the double integral of that, not the double integral. It's over C, then double integral over the region bounded by that. So you see the Green's theorem. You have to read the Green's theorem, right? You need to know the Green's theorem. What is the Green's theorem? It relates the line integral around a simple closed curve C to a double integral over the region R, which is like this. It is del f1 dx plus f2 dy. This is a closed simple over a closed curve, simple closed curve, and then that will be given by this r of this del f to del x minus del f on del y, and r is the region bounded by this closed curve C. Okay, so here also that's how this will be C will be over the region R. We will see what is the okay. So first try to find out what is f1. F1 is x square minus 2xy, 2xy, and f2 is equal to x square y plus 3, right? See, this is f1, this is f2. So then del f1 del y will be minus 2x, del f2 del x will be 2xy, right? So then you need to find the required integral will like transform to 2xy minus of minus 2x of dx dy, right? That's all you get. But what will be the limit of the integration? From where to where this r? This r will be formed. See, the region C is given by x equal to 2, boundary of the around the boundary of the region x equal to 2 and y square equal to 8x. So how it does it looks like y square equal to 8x, y square equal to 8x. So yes, sorry, y square is equal to 8x will look like this because y is symmetric, plus y over minus will give you same. Y square equal to 8x and x equal to 2, y can be anything. So the region will be bounded by this, right? X square equal to 2, y square equal x equal to 2, y square equal to 8x. So for this region, so the r will be then r will be this whole thing, right? This is r. So when this is R, I mean this is R. So R will be then what you can write. X will vary from 0 to 2. X from 0 to 2. Y from this variable to this person to this person mean y square equal to 8x. Y will be minus square root of 8x plus square root of 8x time 2xy plus 2x dx dy, and first we will integrate over y because this is from y to y, and so this will be then 2x times y square by 2 plus 2xy, but which is from minus square root to 8 square of 8x and plus square root 8x dx. So if you do this, then what you get is it will transform to 0 to 2, this one minus square root 8x to plus square root 8x will give you as it is y square. First term will be 0, but second term only you will have, and that will be 4 square root 8 x to the power 3 over 2, which will be 5 over 2 by 5 over 2 times 0 to 2, right? So it will give you 8 root 2 over 5 to the power 2 to the power 5 by 2. If I am correct, that will be the answer. I mean, yeah, 8 root 2 over 5. So if you write this 8 root 8 times 2 root to the power 5 means 2 square times square root of 2, right? So 4 times square root of 2 over 5. So 8 into 4, 32, and times 4 will be 128 over 5. Whatever I got, that is the answer, 128 over 5. So this is correct. Option B will be correct. If you did not understand, please let me know. Is this okay? Can you follow me now?
Yes, sir.
Okay, okay, okay. Okay, so if you have understand this, so then it will be easy for you to do this one also. I mean, this is already you have done engineering mathematics 1, the first course of engineering mathematics, I guess, in NPTEL. So you please let me know what's the answer of this one. Try, we will up. If you cannot, then I will also do. We will do together. What's the answer? Or you are in between?
Sir, C.
C. What you have used then? What is the formula you have used? So have you used this formula? So integration of this as z equal to, for z equal to f of xy, z equal to f of xy, the surface area will be del z del x whole square. We have discussed also in the last class, I think, little bit. Someone had doubt. Square root this dx dy. This is the surface area formula. Have you used this one? We need to, of course, it has to be over.
Yes, sir. Yes, sir. Same formula.
So then what you did, so integration over this one will be, so then it will be f of xy is equal to x square plus y square. F of xy is equal to f of xy is equal to x square plus y square. So del z del x will be 2x, del z del y will be 2y, and this integration surface area will become 1 plus 4x square, because 2x whole square plus 4y square dx dy, right? So integration over 1 plus 4x square plus y square dx dy. But what will be the integration from where to where? Or how do you do that? Next, what you do that? That's what I'm asking.
Sir, 4r square.
Why?
1 plus 4r square. That polar form, sir.
Good, Binoy. Great. So I think he understood and he has done it correctly, hopefully. So sine theta, y, sorry, x equal to r cos theta, y equal to r sine theta. Then what he has done, or what we can do, is x square plus y square equal to r square, and all of us know dx dy is equal to r dr d theta. So integration will be from 0 to 3 and 0 to 2 pi, because r and pi theta you are varying in 1 plus 4r square, right, Vinay? This is what you have done, dr d
Yes,
theta.
sir.
So that will be the answer C. You will see 3 square is 9, 9 plus 4 is 9 times 4 is 36, and plus 1 is 37. So the square root of 37 to the power 3 over 2, that type of things you will see. So that you will see the answer will be C. Okay, the answer is option C will be the answer. Yeah, answer is also given. I will put this all these things in the Google Drive link, and then you see this, the question 3. How to do this? What is the formula for this flux? So required flux will be integration over the surface S f dot n or n vector times d sigma, right? So f dot n you will know because n will be the depending on this function. D sigma also depends on this function. This gradient of f, modulus of gradient f over gradient times e. All those things you will have to find out anyway. So this one is easy for you. Like I am giving you the small a little idea about that. So f is z minus xy and p will be your k cap. Then gradient f and gradient f is minus y I cap minus x j cap plus k cap, and gradient f will be then x square plus y square plus 1. So gradient f dot p will be 1. So and n cap will be gradient f over gradient f over modulus of gradient f. And all this thing if you put, you will see it becomes very easy, and you find out this. It is the integration will be from 0 to 1, and y equal to 0 to 1, x equal to 0 to 1, due to the fact that this is given that over the square x equal to x is from 0 to 1, y is from 0 to 1. Okay. So same question, flux through the vector field. So I'm not going, you just have done all these things. You can see from the notes which I'll share. Okay. So then do this one. This is different. So if is a vector field and C is a closed curve consisting of x and y coordinate axes, that portion and that portion of the circle xy x square is equal to 25 in the first quadrant with z equal to 1. How this will be? First, can you take this theory to use here? This theory can use here.
Green theorem, sir.
Sorry?
Green theorem.
Because Green's theorem was only two directions, like F1 and F2. Here you have F1, F2, F3. what you have in the Green's theorem, f1 times dx plus f2 times dy. The closed integration of that. You have three. You have.
Stokes, sir.
Yeah, that is good. So, but how you proceed with the Stokes theorem? Do it and let me know what is the answer. I will give you time. No problem. So, by Stokes theorem, what is this? It will be the this gradient cross f and the curl of f times this is a vector times the least step, right? This is a Stokes theorem. So what will be this curl of f then? Curl of f or gradient cross of f That will be I cap, j cap, k cap, del del x, del del y, del del z, x square minus y 4z x square. That is equal to minus 4 I cap minus 2x j cap plus k cap, and thus what you get to be over s gradient of f this times minus 4 I cap minus 2x j cap plus k cap times unit normal on the surface S and times dx ds, which will be dx dy, and what will be the unit normal? So C is the closed curve consisting of the x and y coordinate axis and the portion of the circle in the first quadrant with z equal to 1. What is that? I mean, if you draw it like this, if z equal to 1 and x square plus y square equal to 25 will be like this. So the C is the closed curve which consisting of x and y coordinate axis.
सर
Yes.
हेलो सर, इसमें रेडियस दिया हुआ है 5,
Sorry.
रेडियस 5 सेंटीमीटर दिया हुआ है।
Yes.
सर ऐसे सवालों में बाउंड्स नहीं होते, डी एक्स डी वाई के बाउंड्स हो?
dx dy का बाउंड
यस सर, इसमें डायरेक्ट बस रेडियस दिया हुआ है बस, वैसे बाउंड्स नहीं होते, मतलब जैसे कोऑर्डिनेट्स में होते हैं जो पहले पहले वाले कुछ सवालों में थे। एक्स के बाउंड्स, एक्स रे वेरीज फ्रॉम दिस टू दिस, वाई बाउंड रे वेरीज फ्रॉम दिस टू दिस, ऐसे करके।
हाँ, see here x and y maximum from where to where it can bound. It can maximum be like this, right? X and y bounds are already there. X cannot go beyond 5, right? X cannot go beyond 5, y cannot go also beyond 5. But exactly this domain you cannot use, but the maximum value of x is 5, maximum value of y is 5. So if you want to find that region, then it will be x equal to, if you vary x equal to from 0 to 5, y will be from 0 to square root of 25 minus x square. That will be that circular region, right? So you have like this, x you vary from 0 to pi and y is you vary from 0 to 25 x square, and then if you 4 times if you do, then it will be total will be the circle area of that whole domain you can cover. You understand what I'm telling? So in this case, like this, in this case also it will be, see, but it says that the C is the closed curve consisting of x and y coordinate axes, and the circle this x square plus square pi in the first quadrant with z equal to 1, right? All those one with z equal to 1 and x square plus y square equal to 25. Then you have the curve will be consisting of x and y coordinate axes. So I think this is the question in your assignment also. I think can you check it whether it is in assignment also? I'll just let me check it once whether. I have written it wrongly or not. Yeah, so this was the question, but you can. I
it
have
it
also
is
some.
it
Sorry.
is in assignment में है सर ये.
But the language it seems language it seems it is little difficult to read. I mean, like I don't know
It is
some now. Yes.
सिंपली रिटर्न सर, स्टोक्स थ्योरम यूज करना है उसमें. असाइनमेंट में तो सीधा ही लिखा है
क्या लिखा है?
कि यूज द स्टोक्स थ्योरम.
Okay, okay, okay. Yeah, so but how to जैसे C is the closed curve consisting of x and y coordinate axes and the portion of the circle in the first quadrant with z equal to 1. No idea what they are like what they want they mean. I mean, in the first quadrant with z equal to 1 and it consists of x and y axes. See the this circle x square plus y square equal to 1 and with z equal to 1 mean it will be this, right, this type of circle where it is z equal to 1. I mean it's a z axis with its 1 and it is xy, so it will be x square plus y square, circle will be above, and there you need to find out that portion of the C is the closed curve consisting of x and y coordinate axes. Okay. And the portion of the circle in the first quadrant with z equal to 1. Oh, I see. I think this is this quantity only. I mean, yeah, I understand. So then it will be like, you understand now. So you understand what is the what is the curve C? C is the, so C I will write C is this up to this. If we have our coordinate axes like this z, x, y, then the whole green area I defined earlier. So that is full x square plus y square equal to 25 and z equal to 1. But portion of the circle in the first quadrant mean this only, sorry. Portion of the circle in the first quadrant is this, not the other all the portion. I mean this is the projection first of all, but it is first quadrant mean we mean this. So if you have a circle, what I mean, if you have a circle, the first quadrant of the portion mean this, right? Second quadrant is like that way. So, but first quadrant portion will be this. So this is, that's why the C is the closed curve consisting of x-axis, y-axis, and the quadrant of the this circle x square plus y square equal to z. So that's why it is. Then how you can find out?
सर
Like if you have
25 सर ए है सर ए.
A. So now we will see what is the answer. 25 pi by 4.
यस सर.
Good, good. How you did that? Like this?
सर सर दैट मैट्रिक्स है वो सर वो सॉल्व कर लिया वो आईजे के
हाँ.
कोऑर्डिनेट्स निकाल के वो उसमें वो जो z की वैल्यू थी वो उसका हमने इंटीग्रेट सरफेस इंटीग्रल डायरेक्ट निकाल दिया पाई.
Z curve. No, no, no. You can speak in Hindi, but I will be speaking. I can understand in Hindi.
I use the z equal to 1 directly and
Z
then
equal to 1. Where Z equal to 1 directly? I mean, I don't understand. You
surface
are using
integral
1 plus Z del X. That type of, no, what you are using? That's what that one.
सर डबल इंटीग्रल एस
Huh.
एस and then I used that z 1 ds.
This one.
No sir, only one.
You did like this. No, how
Yes
you
sir,
did,
yes sir, yes sir.
right? Yeah, then correct. No problem. Okay. Okay then, right? So can you do then this one? Or I'll leave this one. You want to try this one? You understand using divergence theorem? Just read the divergence theorem, what is given, then you do this one also, and you can do this one also. So flux, again, the flux is, again you can write as this flux. What is the flux? F dot n d sigma can be written as, using the divergence theorem, over that volume, whatever surface you have, that you will turn from the volume times of divergence of f dv. Okay. So what is divergence of A first of all? What's divergence of F? Del x times first component plus del y second component plus del z third component, that is equal to 1 plus 1 plus 1 is equal to 3. So the flux you want to find out, dot nds becomes volume integral times dv. So the measure of the volume, what, 3 times the measure of the volume.
4 pi sir, 4 pi.
Sorry,
4 pi sir, 4 pi.
what, why 4 pi?
सर वॉल्यूम सर 4/3 पाई सर 3 से 3 कैंसिल हो जाएगा 4 पाई और रेडियस रेडियस एक सेकेंड.
Which volume? Volume of what? Volume of is not given some x square plus y square plus z square. It is x plus y plus z equal to 1 and bounded by 3 coordinate plane. Right?
ओके सर. ओके
हाँ.
सर वैसे डाइवर्जेंस में वॉल्यूम वॉल्यूम नहीं कैलकुलेट करते.
डाइवर्जेंस वॉल्यूम।
अच्छा वो सर कहीं सर थ्योरम में पढ़ा था मैंने कि वो दैट कार्ल दैट फ्लक्स इनटू वॉल्यूम ऐसे करके,
Flux into volume, not flux into volume. Flux can be
दैट
written as,
दैट कार्ल
yes.
इनटू एफ इनटू डीवी, दैट ट्रिपल इंटीग्रल वॉल्यूम इक्वल टू एस एफ इनटू डी एस।
हाँ, वो भी पढ़ा था। You have studied that and also you have studied this also, right? Both you have studied. So I saw you where what are the formulas you wanted to. You were telling that formulas are this. F dot.
यस सर यस सर यस सर यस सर यस सर
हाँ,
सर डीवी विल बी सर 4/3 5, that I was saying.
dV is 4 by pi. No, no, no. That is not right, right? How it is 4 by pi?
4/3 pi r square.
No. Why? If your B is your
Sphere. For
sphere,
sphere.
yeah, then only, right? It is not here sphere. That's what I am telling you. I am pointing out that only. It is not sphere here. It will be the volume of the this surface bounded by these coordinate planes. I mean, it will be like this is plane, and then maybe the thing will be like this, right? So this is the whole the and the coordinate planes also, this plane, and this plane. It's
Okay
bound
sir.
that region.
Okay. Okay, I
Understand?
got it sir. I got it. The shape is different sir.
Yes, yes, yes. Like this, right? That type of, oh, it is not the sphere. If it is sphere, then you can say that three times, it will be three times measure of volume, of course. But that volume is not the volume of sphere, it is the volume of this one, right? So that's why you cannot just evaluate it like this. So you have to do it like, let's say x equal to what will, how x will vary. X will vary from, if you see, x can maximum vary from 0 to 1, because the coordinate planes, it will cut this x plus y plus z equal to 1 will intersect at 0 0 1 0 1 0 if it's y axis, and 1 0 0, right? So x equal to 0 to 1, and see x plus y plus z equal to 1, right? You have, so z will be 1 minus y minus x, so 1 minus y minus x, so 0 to that. And when you fix z, so y has to be from 0 to 1 minus x times dx dy dz. Three times, of course, is there. You understand? So if you do it for a small one, you will understand. So this is, let's say, x plus y equal to 1, right? 1 0 0 1. Then what will be the, like, how you calculate volume? For calculating volume, you need to know about this region, like how to integrate over this. I mean, surface in the 2D is, surface is nothing but volume, right? There does not exist any volume thing. So you can see, think it as a volume, like how this is, x is varying from 0 to 1, y will be then varying from not 0 to 1. If it is y also varying from 0 to 1, this, that will give you full thing, this square. But y is varying from 0 0 to this portion, this point, so which is varying by how, x plus y equal to 1. So this point always will be 1 minus x times 1 minus x, that point. So y should vary from 0 to 1 minus x, and x will vary from 0 to 1. That will give you this whole region, right? So that is a simple exercise, you can just think about it. So that's how it will be like this. And then what is the answer? Tell me.
सर -3/2 जा रहा है इसमें तो।
Minus 3 by 2. No. Minus 3 by 2 cannot be. See. You see this.
अच्छा सर, वो कैलकुलेशन में थोड़ा सा ना।
You check it with your calculation also, okay?
ओके सर।
Okay?
यस सर, यस सर।
So again, using Stokes theorem, this one you can do it. So this one, try this one. Then one more question, then we will stop. Okay. Evaluate the integrals means both the integral you have to find out. Like first you find out the
जैसा कल वो कल पता कर रहे हैं सर वो मैट्रिक्स बना के सर
no problem. So you know the divergence theorem is the integration of that one f dot ds that is equal to v divergence of f. Not curl, it is divergence, okay? Because it is divergence theorem given that, right? So you have to find these two, and you can check. Mainly, it is given to check whether both the thing works. Both the things are equal. It most probably it will be, but you want to check it. Sorry, second integral. This is not factor 10. The right hand side integral is okay, right? That you can easily find out.
सॉल्व सर
What is the answer?
सर नो सर वो कैलकुलेशन मुश्किल यहाँ पे फंस गया सर
You see first. I will not show full answer. First, you see this. This is okay.
यस सर यस सर
So now you do the second part. I mean, second part means the left hand side one. Okay. F dot ds you try to find out. This one is okay. So, but you know the answer will be 554 pi. But you have to find out the surface integral, mainly this. Draw the region first. D. What is the region? D. 1 or 2 minutes. I will be like you do it. I will be waiting. Hello. So the hemisphere will be the hemisphere bounded by z equal to 1 plane, right? So first of all, how this hemisphere looks like, how this sphere look like, x square plus y square plus z minus 1 whole square equal to 9. So this one you can say x square plus y square plus z minus 1 square is equal to 9, I guess, right? And z will be equal to, yes, see, z equal to 1, right? Or z equal to 1. Can you see the image? See, this is the
Yes, sir.
hemisphere. So your region will be the first one. I mean, the z equal to 1 plane is the blue color above that, right? So that you can divide like the hemisphere, upper part of the hemisphere, which is this, you see, x square plus y square plus z minus 1 whole square, and another, this is s1, and s2 will be, see, the plane z equal to 1. So you have to mainly integrate over that, that's all, right? Okay, so that's all. So you have any doubt here in this last question? Is it okay? You understand?
Yes, sir. I will practice, sir.
You are practicing? Sorry?
Yes, I will practice these questions because एकदम से नहीं हो पाते हैं, वो समझना पड़ता है मेरे को.
Huh. So here you want. So anyway, I will be sharing this one in the Google Drive. Or also, if you are trying, also I can know it. I can know it if you want to try also. If you have any question, you ask here also. That's not a problem. If you want me to stay for 5 minutes, I will wait. If you want to do that, also no problem. What you are telling, you say just. I mean, what is your what you want to say?
I will practice, sir. वो
Okay.
assignment questions I will practice.
Okay.
Then only this question can be done.
This is also assignment question. Oh no, this is, I think this is not assignment question also. But yeah, these are same. Okay. Anyway, you have to. This is the same thing. I mean, you have to do the integration of this function f over the region x square plus y square plus z minus 1 whole square equal to n. Okay, that's why the surface equation f, I mean that is g. This you gradient of g over gradient g. So that you have to find out. Then what is n1? N1 will be the, sorry. What is d sigma? That d sigma will be the surface area of the that surface. So then you get the surface area of the hemisphere will be 18 pi. That's how you get 54 pi. Okay. So that will be easy. Okay, you can do it because you have done other things, so you can do this, I think. And yeah, I have to share. Last time I haven't shared the this PDF, but today I will share the PDF also. Okay, then you can see. You can see in the Google Drive link. There also you can find all these things. And if you have any doubt, please let me know. Just send a message or send a mail. You can send me mail also here. I just write it. Rahuldev 19 at the rate istvm.ac.in. This also you can say, you can put I will be uh, uploading these videos in the YouTube. There also you can ask wherever you want. It's open to you. Anytime you ask. Okay. You let me know if you have any doubt. Okay. I can feel that you are trying a lot. You will get, but yeah, that's why you will understand everything. That is not a problem. But and also we are. I am telling you that whenever you have problem, you just reach me out. That's all. Okay.
Okay, sir. Sir, ये कल जो है rotational behavior, there will be questions on this also.
This is Stokes theorem. No, this is Stokes theorem. See, this is a curl. Gradient f. This means curl. That is equal to curl. Integration over. This is curl. Nothing but curl of f dot ds. That's the meaning of curl. Nothing else. It's just gradient and cross f you have to find. But mainly, what I will say, you just be very familiar with these two. Very familiar with these two. Surface integral. Okay. So one of the most important thing. So you were feeling a difficulty. That is also surface integral, nothing else. That is surface integral. So surface integral, one has to be very clear about that.
But parameterizations.
That is not in this course, but I mean not this class. And the other last class I told that they are, yeah, parameterization also. But in for this week, it is these two you have to do.
There will be less questions on spreading that sink strength divergence.
Divergence and curl. No, there can be one question because there, I think one full class was on divergence theorem, right? This
Okay,
is
sir,
easy.
go on.
Divergence is easy. See, divergence of f. Just you need to remember this. You just take derivative of this with respect to x, derivative of this with respect to y, derivative whatever the function you have. You just take derivative and add. That is divergence. If you want to do the curl, find out the curl, then you have to do this I cap, j cap, k cap, and then del del x, del del y, del del z. You put, and then again same f1, f2, f3. That is curl, and divergence will be del del x of f1 plus del del x of f2 plus del del x of f3. Remember that this is a scalar function, this is a vector function. This will give you vector. Curl of a vector field will be vector again, and divergence of a vector will be scalar. So that's why you will see when you are see here the theorems. So divergence, whenever it's a divergence, it's a the divergence of f is scalar. This product is scalar, so divergence, this is vector. F is vector, but f dot ds is scalar, and here you see gradient of this divergence of f is scalar. Here you see f dot dr, f is vector, gradient of f dot ds, that's why, because gradient of is vector. So this is a vector, and these are two different things. When it's a it is curl means it describes how rotation at every point on S influence the circulation along the boundary. So it gives the rotation behavior, and wherever divergence means how much how much of a field spreads out or divergence from a given region. These are two different things, but you don't need to remember all these things. Just remember these two. Try to remember these two formula. You
Surface
just
integral, sir. Surface integral.
and surface integral, these two and these two very much. These two you remember the formula. Also do lot of questions on it. Try to at least do 2 3 questions for do these two types, and then you do these two little bit. That's all. I think it will be okay for week 2.
Okay,
And
sir.
Green's theorem is easy, right? Green's theorem is you can remember. That's why I am giving a like the very brief recall of whatever important things are there. So if you remember, if you know all these things, you know everything. That's all. What you do, you try to read this formula and try to do the questions in the assignment. You know the formula at least. If you don't want to read all the things, you do whatever I have said. All this formula you write down and try to do the questions from the assignment. We try to understand the formula and use this in assignment. Use this to solve the assignment. That's all. If you can do, then you understand the theory. You have understand. Okay.
Okay,
Then
sir.
see you. Thank you for your attention. Okay. I'll end the meeting here.